Okay, so we're starting section 8.1. We're really starting to deal with what are called counting problems. These are problems where you're just trying to figure out the number of ways that things can happen. So we're going to start off with this example. We have a breakfast that consists of one pastry, for which you can choose a bagel, a muffin, or a donut, one beverage, for which you can choose coffee or juice, and we're trying to figure out the total number of different breakfasts you can have. You can see this is kind of represented by a tree diagram here. Your first choice is what pastry you're choosing. And then given that pastry you've chosen, you can either choose coffee or juice, coffee or juice, coffee or juice. So right here, you've chosen a bagel with coffee. Here you've chosen a bagel with juice, and so on. You can see there are a total of 6 different choices. And based on this tree, you can see if I'm splitting 3 times, and then each of those are splitting by 2, we get 3 times 2. This is essentially what the multiplication principle says. If you have choices to make, so if you're making repeated choices, and there's a certain number of choices to make the first decision, and then a certain number of ways to make the second decision, and each branch along the way, it's the same. So this is our first choice, and this was our second choice. There were 3 different ways to go with the first choice, 2 different ways to go with the second choice. To find the total, we do 3 times 2. In general, if we kept that up, you could do it, you could have 6 different ways for the first choice, and then 4 different ways for the second choice, and then maybe 3 different ways for the third choice, and then 5 different ways for the fourth choice, or whatever. If you were just to multiply up the total number of ways you can make each of these decisions, this would give you the total number of branches if I was to draw out that entire tree, which, yeah, I'm not going to. So if we had something like this, that's what the multiplication principle says. A certain combination log can be set to any 3-letter sequence. So I'm first going to figure out how many such sequences are available. Well, 3-letter sequence. First, I need to say how many choices are there. Well, there's 26 letters in the English alphabet. There's 26 letters in the English alphabet. So that means essentially if we're doing a 3-letter sequence, that means the first letter can be any of the 26 letters. The second one can be any of the 26 letters, and the third can be any of the 26. So in total here, we're making 3 decisions. Each of those decisions has 26 different ways we could go with it. So 26 cubed, 26 times 26 times 26, is, I don't know, some number, 17,576. I'm less interested in this number, more interested in how we came up with it. So 26 times 26 times 26. All right, how many such sequences are possible if no letter is repeated? So again, we're in a situation where we have 3 different choices that are being made. And for the first choice, there are 26 different choices because you can choose any letter for that first letter. But when you come to choose that second letter, you can't reuse the first one. So now there's only 25 that are available for the second letter. And then for the third one, there's only 24 that are available. So we get 26 times 25 times 24, which gives us 15,600.